When I look at simulation consulting and simulation in general, it's this idea of a nice mix of science and art, because you have to understand the system level thinking that we learn as industrial engineers. You have to understand how to program, but there's also this idea of this level of abstraction.
What I think makes us special, what makes us different, is that Mosimtec works on nothing but simulation-based projects, using simulation tools that will fit that project.
We've already seen in our world these days how much the world is changing with technology, how much the world is embracing and adapting to it. And I feel as though traditional consulting methods are starting to become outdated. So I do believe that simulation modeling as a whole will become more prevalent and a more popular method.
From there, over the last 10 years at Mosimtec, we've really broadened out into many different industries. I believe there's any and all industry can benefit from modeling and simulation.
Each project can range from a number of different industries, keeping things interesting. Projects could involve manufacturing, fast food, hospitals, airports. I mean, the list goes on for us.
So what I like about Mosimtec is it is really focused on simulation, and then all of the partners and people that work for Mosimtec understand simulation.
The future of simulation modeling is really more simulation models, more pervasive. So companies that have been sitting on the sidelines or haven't used simulation models in the past, they'll start to realize the benefit and start adopting this discipline.
We have some clients that I've been working with for 15 years, maybe a small project a year. So kind of having that long-term relationship too with the clients that really rely on us, and knowing that we're helping them, solve some pretty important problems.
Some people think what I do is like Star Trek stuff. It's just amazing what you can do building these models and the kinds of answers you can get out. The folks that are my friends that are a little more technical probably think I'm pretty lucky to be able to do what I do, and I think so as well.
Hi, I'm Jeff Brelsford with Mosimtec, and today I will be reviewing some techniques for using Simio's dispatch rules and source arrival logic in a manufacturing-based simulation in an effort to maximize throughput while meeting service levels. Many manufacturers have two primary and competing objectives for their businesses. The first is to maximize system capacity by producing as much as possible within a certain amount of time. And that time tends to get shorter and shorter. The second is improving service levels, which is synonymous with reducing lead times. Both objectives require production management techniques that are at odds with each other. That is to say that to achieve the goal of the first, one risks a negative impact on the other. Maximizing system capacity is achieved by, among other things, reducing changeover and setup times. This focus on reducing total time in system, however, disregards the importance of due dates, which are important to maintaining service level agreements. In this session, we'll discuss techniques for implementing these production management techniques using Simio's built-in dispatch logic. We will also review the combination of two dispatching rules to achieve their greater benefits together. Lastly, we'll use the dispatch logic with the source object's arrival mode and time property to reach even higher levels of throughput. So what does dispatching mean? Dispatching means that work, namely production orders, are assigned to a specific resource at a certain time. In more simplistic terms, it is the selection of an order for processing among available orders. We will use Simio's server as the example for how to integrate the dispatching rules into a manufacturing-based simulation model. Dragging the server into the facility window, we can see in the process logic section a property called dynamic selection rule. The help guide at the bottom right states that the dynamic selection rule indicates whether this resource, when its capacity becomes available, dynamically selects the next seize request from its statically ranked allocation queue using a dynamic selection rule. Another way of saying this is that when the resource has been made available, it will choose the next entity for processing based on a predefined rule. Opening the drop-down for this property will choose the option Standard Dispatching Rule, as this will inform the server to use a dispatching rule when selecting an order. This is done with the dispatching rule property and the dynamic selection rule repeating property. This can be created by either selecting the enumeration property in the definitions tab or right-clicking the property in the server and selecting Set Reference, and then Create New Reference Property. The property type is an enumeration, and the enumeration type is Simio Selection Rules dot Standard Dispatching Rule Definition and Dispatching Rule. The new property, which we'll call Dispatching Rule, has several options to choose from, but we will consider only 3 for this technical discussion. They are first in queue, least setup time, and earliest due date. The basic algorithm used by many manufacturers is the first in queue, where the first order that is in the queue to be processed is selected. Many manufacturers tend to use this option because it is extremely simple to manage. Whether paper travelers or digital work orders, the selection is simplistic and does not take sophisticated software to manage its order throughput or order sequencing. It is, however, least effective for maximizing productivity. The next algorithm we'll look at is least setup time. This dispatching rule selects the next order from the queue of orders which has the least setup time. As one might realize, systems with none or very little setup times, like continuous production systems, may not benefit from this rule. In our manufacturing example, however, our setup time can be as high as 19% of the total time that's needed for a machine. This has a substantial effect on equipment production, as it is a non-value add activity, and we would certainly like to reduce it as much as possible. The last dispatch rule we'll use is earliest due date. As the name might suggest, this algorithm selects the order with the earliest due date. In this example, all orders have a ship date, which is the date when the order is supposed to ship. Not necessarily the date it's due to the customer. Manufacturers who have more strict service levels and higher OTIFs use this dispatch rule quite a bit. OTIF, or OTIF, stands for on time and in full. It is a 0 or 1 assignment to an order. If it ships on or before the due date and in the amount stated by the contract, it gets a 1. Otherwise, it gets a 0. Summing the OTIF values for the orders and dividing that by the total number of orders shipped gives a service level ratio. The more orders ship on or before their due dates, the higher the total OTIF and the higher the service level. So the trade-off between least setup time and estimated due date might not be clear, which is, all things being equal, that what you make up for in OTIF, you lose in capacity. Another way to consider it is that when the focus is on meeting due date deadlines, there's greater emphasis on getting orders to not be late compared to processing as many as possible. Now that we have an idea of the dispatch rules that we're going to compare, let's take a deep dive into the example model itself. This example mimics a real manufacturing system and contains a 3 work center system comprised of 3 servers. The 3 work centers are in series, and the system produces widgets that have orders that will follow one of 2 routes. They either start at work center A and then go to work center B and then on to C, or when they enter the system, they go directly to work center C. In both cases, the orders are processed last at work center C and then sent to shipping. Work center C is the bottleneck of the system, and we can use its hourly throughput to represent the system's throughput. Since we are not concerned with material handling, simple connectors will suffice between the work centers. I have chosen to apply the dispatch logic to all 3 work centers to increase the effect for demonstration purposes, but it could conceivably be applied to few or 1 if the dispatching rules are very complex or very complicated to administer or implement with other work centers. our model will have each work center assigned with its own dispatch rule settings. All order data and product data are maintained via data tables. There are approximately 1,000 orders and about 120 different SKUs. And each SKU has different processing, setup, and changeover times for each work center, all maintained by the materials routings. Let's now turn our attention to the experiment section and set up the first scenario by selecting first in queue. When we run the scenario with first in queue, we see that the output has a throughput of 14,043 units per hour and an OTIF of 74%. This means roughly 1 in 4 orders are late, which is a pretty bad service level. Orders have a cycle time of about 21 days. Now let's prepare the second scenario and run lease setup time. We see that Work Center C has a throughput of 14,620 units per hour, which is about a 4% increase from first in queue. But the OTIF increased by 20% to 89%, which is a substantial increase in service level. Cycle time drops to 12 days, also something we prefer. Next, we prepare the third scenario. When we run earliest due date, we see that Work Center C's throughput drops to 13,802 units per hour, which is about a 2% decrease in throughput compared to first in queue. And this is certainly not something we want to have happen in our real system. OTIF, on the other hand, is significantly better at 94%. Both of these make sense from the standpoint that batching similar orders, in the case of lease setup time, lessens the amount of time that the average order spends in cycle. And therefore, the result is an increase in product production per time period. Earliest due date, on the other hand, prioritizes delivery objectives, and thus service level increases as most of the orders meet their due dates. Naturally, a next question would be, how can we get the best of both of these rules? How can we get an improved throughput from using lease setup time and simultaneously improve our service levels using earliest due date? We can do this by cascading the rule sets so that the servers evaluate multiple dispatch rules in order. And this can be done by using the repeat group property within the dynamic selection property of our server. When we turn this value to true, we can see the dispatching rules change to repeat property. We will open this up and enter 2 rules into the repeat property editor. A key point to note is regarding rule configuration. The servers apply the rules in the order listed. So whatever rules you choose, you need to think about how they will be applied. In our example, we want to both ensure that we batch-like orders, similar orders that is, using lease setup time, but also ensuring that orders meet their due dates or ship dates. Considering this, we can create a property that is used to evaluate whether an order should be dispatched before others that are closer to its due date. We can call this property a due date window and use its comparison as our first and higher priority check. The general equation is an inequality equation built inside a logic statement. The equation is the candidate ship date subtracting the current time is less than the user-defined due date window. We want this to evaluate to either a 0 or a 1, where all the orders that have 0 will be selected over the orders that have a 1. We should also control whether this logic is implemented or not. So we can add a Boolean or an enumeration property. In this case, I will use an enumeration property as this is a user-defined input for experimentation, and I feel like there's less room for error in the experimentation section if we use an enumeration versus a standard Boolean. We'll call this property due date window on. Let's add that to the attribute value expression. Now, we've set up our earliest due date proxy by having Simio first evaluate which orders take priority because they have sooner due dates. We then need to add some logic that dispatches based on lease setup time. So let's add another rule in the repeating property editor. I want to give some flexibility to both the type of the rule and for which work center. So let's create a new reference property for each work center and name it accordingly. Now let's run 3 scenarios. We'll run one scenario that has the due date window set to 0 days, which makes the orders that are due within a 24-hour period higher priority. We'll have another 2 scenarios where the due date windows are set to 5 and 10 days. This will allow the servers to choose more orders in advance for processing. In the scenario with 0 days, the throughput at Work Center C is 14,620 units per hour, which is 4% higher than first in queue and the same as the least setup time scenario. It has an ODIF of 86%, which, while an improvement compared to first in queue, is not on quite the same level as least setup time scenario. In the scenario with 5 days as the due date window, we get the same system throughput of 14,620 units per hour. But our ODIF has an improved 91%, which is great progress, but still doesn't match the pure play earliest due date scenario of 94%. So far we haven't been able to completely improve upon a previous examples of individual dispatch logic. Lastly, let's run the scenario with 10 days as the due date window. And we get the same throughput, which is 14,620 units per hour. This might be the max. But this time we get an ODIF value of 95%, which is the best result yet. This combination results in the benefits that we were hoping to get and shows us the power of simulation using Simio's dispatch logic to achieve that. On the downside, however, we are extending our cycle time by a day compared to the least setup time, but our service levels look good and we're getting the throughput values we need to achieve. This could mean, however, higher working capital as WIP and finished goods inventory quantities and their time increases. There's another challenge in that it's implementation in the real system. It's very easy for these servers to prioritize, calculate, dispatch, etc. But for humans to do that takes coordination. So the complexity lies in the management and execution of these orders as they are making their way through the real system. The last part of this technical discussion is regarding order releases. There's an additional layer of logic that we can add to the model that will push the system to even higher levels of productivity. And that has to do with releasing orders. In our current setup, orders are released based on their sales order date, but it does not have to be the sales order date. Typically, release dates are calculated by MRP or some other internal release mechanism that the organization has. But our goal is to allow for a number of orders to enter the system prior to their release dates, and then let the servers make the selections as to who goes first. We can do something similar to due date window, in which we used the earliest due date, and we mimicked the earliest due date in the server logic by creating a new property that we use to determine when to release an order. We can do that by creating this real property called look ahead window. We'll use this in the manufacturing orders table in a new expression property column called rolling look ahead. In the expression, we need to subtract the rolling look ahead window from the release date, and in this case our sales order date, to create a negative, positive, or zero value. Because what we're trying to do is trying to determine if an order is within the window. So we'll put this function inside a logical max. So when we have a 0 or negative, the function will return 0, thus making its time for release immediate, right now. When we have something greater than 0, the order will be released at a later time. In our source object, we'll continue to use the arrival table as the arrival mode, but we'll create a new property for the arrival table which will allow us to toggle between using the sales order date or our new rolling look ahead as the date and time for when the order needs to be released. Let's now run a scenario using the defaults for the earliest due date and least setup time combination, and 5 days being the due date window. Now let's select the look ahead type to be rolling look ahead and the look ahead window to be a month, 30 days. This means that any orders which have a sales date within 30 days at any point in time in the model will be released. As we see in our results, our throughput has reached new heights as we are now at an astounding 15,938 units per hour, which is a 13% increase from our first in queue, our largest throughput at this point. We also have our highest OTIF, at 100%. At first glance, this appears to be the best system configuration yet, looking at those same metrics that we have been, throughput and OTIF. But until we start looking at the average days in inventory, we see that our days in inventory are twice the duration as the next highest. This is another trade-off. This is the trade-off for maximizing unused capacity as soon as possible. And that is that finished goods will be done much sooner, and thus potentially sitting around for a considerable amount of time, tying up working capital. We have looked at a few ways to effectively utilize Simio's built-in dispatching logic to improve manufacturing productivity. We've also discussed a means of throttling work and increasing throughput to even higher levels by using source arrival logic and data tables. I hope this technical discussion has been insightful and beneficial, and look forward to your questions and comments. Thank you.
Jeff, thanks for a great presentation. Sorry, I thought I was on mute. But first question from the audience. Can you use the Gantt charts or other reporting methods within Simio to verify the behavior of the dispatching roles?
Hi, thanks, Eric. Yes, so Gantt charts or the dashboards, I mean, you saw in the presentation, I used a few pie charts to look at utilization and the subsets of utilization like setup times and all that to get a quick idea, I suppose, as to whether dispatching rules working well or not. And same thing within the Gantt charts. You can see the orders and where they're lying. Hopefully, within a reasonable amount of orders. If you've got a system that's highly flooded with orders, then it can pretty much overwhelm the senses almost when you're looking at these Gantt charts. But you can start picking up patterns too. So, for example, least setup time, I should be looking at the Gantt chart, or I should see in the Gantt charts, lots of throughput, i.e., orders finishing, on time or well before their due dates, often crowded together quite a bit too, versus let's say least setup time, where there's probably a little bit more in the way of gaps between orders. But certainly once you overlay any sort of targets in there, that's going to perform a heck of a lot better, and you should be seeing that within the Gantt charts.
A question about your model data. Did you create the model data tables from scratch, or did you use a template? If you did use a template, is it publicly available?
Yeah, so for this model, let me see. I mean, so for this model, no, we didn't use the the Simio templates, but I am so familiar with using the Simio templates that for manufacturing ISA 95 base templates, that I often start from there and will remove as needed. So say time and time again, manufacturing orders are going to be a part of your manufacturing model, so they'll be included in there. You're going to have a materials master, so that's going to be in there as well. Routings data. You're always going to have routings data, but maybe not necessarily in the same format as Simios or ISA 95s. And so that for me personally, I'll start looking at that probably more than I would the manufacturing orders data or resources tables, because I know I'm probably going to spend more of my time in that routings data. So it's yes and no. You start with the templates, you remove as needed, and then you add where you need to.
Another question around data. What source data systems do you typically import order data from? Do you use historical data or forecasted futures value?
So all of the above and then some, right? We've had the pleasure of working for, several hundred, working on several hundred projects in the past few years in many Fortune 500 companies and Fortune 1000 companies. And the sources of the data range from, CSV files, Excel sheets, to databases, pulling directly from SAP, pulling from SQL Server, pulling from an Oracle database. So it's where is what is the source of truth for each of these organizations? When it comes to data is dependent upon the organization itself. Most of the time, and I think that that's a bit of an obvious statement, but most of the time, order data in particular, I would say by and large, comes from either the ERP system or Excel, depending upon the size of the organization or the size of the location that we're looking at. So those are the two main areas. Outside of that, and then within the ERP system, it's primarily SAP. But we've run across a few other ERP systems as well. I'm sorry, what was the second question? So those sources of data, and then
is it historic or forecasted future values?
Yes. So it's both. Generally, we start off with historic data. That's data that's readily available. That's usually where the analysis, begins, at least, as far as validating the model, validating the project, and some current system state analysis. Where's the bottleneck? What's the level of throughput that we could expect, given the system as is? And then we layer in, future orders. That's either done directly by the client. So the client says, "Hey, I want you to use these orders over the next 5 years, 10 years," or we work with the clients in developing some randomly generated orders, whether that logic is built into Simio or whether that's built externally, and let's say Excel using some VBA or Power Query or something like that, is all dependent upon how granular they want to get with an order, and whether what's the timeline on the project, of course.
Okay, thanks, Jeff. Thank you so much for presenting today at our Simio Sync, and thank you to all the team at Mosimtec. If you have any other questions, feel free to reach out to Jeff through the platform or just go to mosimtec.com. Thanks again, Jeff.
Thanks.